Hey guys, what's up? This is Vijay Kumar Sen and you are watching Vijay Kumar Sen English YouTube channel. So guys, in this lesson we'll discuss 20 more questions. Alright, so let's move on. So in this question what we have given, in a refrigerator, the evaporator and condenser coil temperatures are minus 33 degrees centigrade and 27 degrees centigrade respectively. Assuming that the maximum is realized, the required power input for a refrigerating effect of 5 kilowatt. So we have to find out power input. That means work input we have to find out. So we know that COP is what in case of refrigerator minus 33 plus 273 division 27 plus 33 is equal to refrigeration effect upon work input. So we just need to this value to this side and this one is on the upper side. That is our required, we have to find out that. So 4 kilowatt division, we have to find out that minus 33 plus 273 240 division, my dear, 27 plus 33 is how much, my dear? 60. So 4. That means, my dear, refrigeration effect is 4 kilowatt division COP is getting 4 from temperature terms, in terms of temperature. So what we're getting, my dear, after calculation, 1 kilowatt. Therefore answer for this question is D. Maybe guys, if you're new, then maybe you're facing here problem. So COP formula for refrigerator is TL by TH minus TL. That is why, my dear, we have written there minus 33. We have to convert this into Kelvin, 273, and whenever there is difference, no need to convert it to Kelvin. So my dear, 27 minus plus 33. That is why we have written that, right? Now let's move on to the question number 82. The refrigeration system of an ice plant working between temperatures of minus 5 degrees centigrade and 25 degrees centigrade produces 20 kg of ice per minute from water at 20 degrees centigrade. The specific heat of water is 4.2 kilojoule per kg and latent heat of ice is 335 kilojoule per kg. The refrigeration capacity of the refrigeration plant is, we have to find out that. My dear, if you're following my each and every lessons, each and every question, then you must know how to solve this question, because we have to find out only refrigeration effect. We have done this earlier. So for finding out refrigeration effect, we know the formula mass CPW multiple 20, that is the temperature, addition latent heat, that is we have given, right, latent heat. So after putting all the values, we can get the answer. Mass is what, my dear? 20 kg. CPW is what? 4.2, 20. Okay, latent heat how much, my dear? 335, right? So let's do it. 4.2 multiple 20 plus 335. Okay, let's check the unit. All of these units having same unit, right? So no problem at all in that case. So what is the answer we're getting, my dear? That is okay. Again, my dear, one thing I have to check, my dear, that is what? 20 kg of ice per minute, and here also asking in per minute. That means all are okay with the unit point of view. So multiple 20. So answer we're getting after calculation 8380 kilojoule per minute. That means option C is the correct answer for this question. Question number 83. The coefficient of performance of a heat pump working on reversed Carnot cycle is 6. If this machine works as a refrigerator with work input 10 kilowatt, the refrigerating effect will be. Okay. So my dear, what we have given, just look at this. COP we have given, right? But if it will work as a refrigerator, so we know that there is a relation, my dear. 1 plus COP of refrigerator is equal to COP of heat pump. Therefore COP of refrigerator is equal to 6 minus 1 is equal to 5, because COP of heat pump we have given, right, 6. So COP of refrigerator is equal to, for the same temperature limits, is equal to what? 5. Therefore COP is equal to what? Desired effect upon work input. So my desired effect is what? That is refrigeration effect. That is exactly we have to find out in this question. Work input is how much? 10 kilowatt. So just do cross multiplication. Refrigeration effect is equal to 50, 10 kilowatt means 50 kilowatt. Therefore option D is the correct answer for this question. Question number 84. Consider the following statements. First, heat pumps and air conditioners have the same mechanical components. Of course, this is the correct one. Same system can be used as heat pump in winter as air conditioner in summer. Yes, it can be possible. Next, the capacity and efficiency of a heat pump fall significantly at high temperature. My dear, it can be proved, right? Look at the options, right? So we know that COP, we will find out COP over here. COP is what? TH by TH minus TL. We can do that, right? Very simple. My dear, look at this. Let's consider first condition. TH is how much? 20 and TL is 10. Consider another case. TH is 30 and this is 10. If we'll do it, my dear, if we'll do this calculation, right? So 30, okay. For this case, what are you getting, my dear? 20 plus 273 by 10. For this case, we are getting 30 plus 273 by 10. Just do calculation. 293 by 10 is how much we are getting? 29.3. And for this case, my dear, 30 plus 273 by 10, that is what? 30.3, right? So in this case, what we are getting, my dear? 30 plus 273, okay. No, this will be 20, right? Okay, so there is some calculation mistake. So 30 plus 273, okay, division 20. So it is, my dear, 15.15. So for this case, my dear, we are getting 15.15. For this case, we are getting 29.3. That is why, my dear, what we can say that all the options we have given, because whenever temperature is increasing, the lower temperature is same. In that case, what is happening? It's, my dear, COP is decreasing significantly, as we have given in the in third statement, right? Therefore option D is the correct answer for this question. Question number 85. An ideal refrigerator working on a reversed Rankine cycle has a capacity of 3 tons. The COP of the unit is found to be 6. The capacity of the motor required to run the unit is, my dear, again we have simple question. COP of the refrigerator is equal to desired effect 3 multiple 1 ton of refrigeration, 1 TR is equal to 3.5 kilowatt. So we have to multiple this 3 multiple 3.5 kilowatt, division what, my dear? Work input, which is it is basically asking, right? Capacity of the motor required. So work input is equal to what? 3 multiple 3.5 division COP of the refrigerator is 6. So 3 multiple 3.5, that is what? 10.5 division 6 is equal to 1.75. Therefore answer for this question is what? Option B is the correct answer for this question. Question number 86. A cold storage has capacity for food reservation at a temperature of 3 degrees centigrade. When the outside temperature is 27 degrees centigrade, the minimum power required to operate with the cooling load of 90 kilowatt is. So we have to find out minimum power required. That means again might have to find out power required, that is work input for this case, that is for this cold storage. So we know COP of this refrigerator, let's say refrigerator, right? TL by TH minus TL is equal to desired effect, that is 90 by work input, right? So there is no problem with the unit, we have same unit given, right? So TL is what, my dear? 3 plus 273 and in the denominator 27 minus 3 is equal to 90 by W. Simplify and tell the answer, right? Let's solve it. 3 plus 273 division 24 and 90 division, the answer is 7.8. So kilowatt, right? It is equivalent to almost, the closest answer is what? 8 kilowatt. Therefore option D is the correct answer for this question. Question number 87. Cold storage is to be maintained at minus 10 degrees centigrade while the surrounding are at 30 degrees centigrade. The heat leakage from the surrounding into cold storage is estimated to be 29 kilowatt. The actual COP of the refrigeration plant is used 1/3 of that ideal plant working between the same temperature. The power required, matter again we have to find out work input. So but here we have to use this also 1/3, right? So we know that actual is equal to what, my dear? 1/3 of maximum. How we can able to find out maximum COP? That is only possible in terms of temperature. So minus this 10 minus 10 plus 273 division 35 plus 10 45 is equal to desired effect upon 29 upon work input. That is we have to find out. Simplify this and tell the answer. So my dear, I am giving you task. Just solve this question and give the answer. Write the answer in the comment section. Which option is correct according to you? Question number 88. A reverse Carnot engine is used for heating a building. It supplies 210 multiple 10 to the power 3 kilojoule per hour of heat to building at 20 degrees centigrade. The outside air is at minus 5 degrees centigrade. The heat taken from the outside will nearly equal to. So we have to find out heat taken from outside nearly equal to, right? So it is very simple question, my dear, but we have to use the concept of what? We have to use the concept of the very simple concept, the very simple thing. That is what, my dear? How the heat taken from the outside, right? So here is the catch, madam. What is the meaning of heat taken from outside? That is the catch over here. So we have to think about that, right? If you can able to understand that, definitely we can, we can easily solve this question if we can understand that what is it basically it is asking, right? So you need to find out that. Okay. So my dear, first of all, it is saying it supplies 210 multiple 10 to the power 3 kilojoule per hour, right? It is supplying. Okay. So first of all, draw that is what? Heat engine. It is saying it should be heat engine and okay. So this should be heat pump, right? Not heat engine. So this should be like this, all right? And this is work input, all right? So it supplies 210 kilojoule, that is 210 kilojoule 10 to the power 3. We have to find out this one. That means we have to find out Q1. We have given Q2. We have to then find out W. Able to find out Q1, we need to know the value of W. So how we can able to find out W? That is also a challenging task for us. It is a heat pump. So my dear, we can find out COP is what? Desired effect, that is 210 multiple 10 to the power 3 upon work input. And we can find out COP in terms of temperature because we have given that. So how we can able to find out that COP in terms of temperature? That is what? 20 plus 273 division TH minus TL 25. Now after simplification from these two, what we can able to find out? Let me tell you. 20 plus 273 division 25, right? And 210 division answer, that is we're getting 17.9. we're getting work, that is work done. Now my dear, we have to subtract this from 17.9 because we know that from first law of thermodynamics, Q1 plus W is equal to what? Q2. So Q1 is equal to what? Q2 minus W. So 210 minus that. So what we're getting, my dear? 192 multiple 10 to the power 3 kilojoule per hour. Therefore option A is the correct answer for this question. This is an amazing question, my dear, right? So you should focus on this type of question and mark mark some kind of notation that yeah, these kind of questions can be useful for further examination, right? Question number 89. Consider the following data referring to a refrigerator working on vapor compression refrigeration cycle. Enthalpy, okay. For this type of question, at least for VCRS, my dear, draw the TS diagram. It will be quite easier to solve the problem, as well as, my dear, you will come to know one thing, that is what? Where you will make mistake, right, for while solving. So we have given H1, we have given, and H2 we have given, and we have given S3. But we know that, my dear, S3 is equal to H4 because here isenthalpic process is going on. That means enthalpy is constant, but in that case pressure is dropping. So my dear, COP, what is the formula for COP of the refrigerator for VCRS? H1 minus H4 by H2 minus H1. So H1 is H4. What is the answer we're getting? H1 is H4 is H1 is what, my dear? 180. H4 is how much? 60 by H2 210 minus how much, my dear? That is 180. H2 minus H1. So 180 minus 60, 120, and 210, 180, 30. So this can 0 cancel, so 3 4. So option C is the correct answer for this question, right? Simple question. 90. In case of vapor compression refrigerator, if the condenser temperature of the refrigerant is closer to the critical temperature, then there will be, first, excessive power consumption, high compression, large volume flow. Which of the above statements are correct? 1 2 only, 1 3 only, 2 3 only, 1 2 3. So my dear, see, whenever this is the case, in that case all threes are happening, all these three are happening, my dear. So always remember this point also, because these things can be it is difficult for that it will repeat, but maybe they will repeat this question. This question asked in ESC, my dear. Question number 91. Consider the following statements in respect of vapor compression refrigeration unit. First, actual units of the refrigerant leaving the evaporator is superheated. Actual unit of the refrigerant leaving the evaporator is superheated. Yes, it is possible. Superheating of refrigerant at exit of evaporator increases the refrigerant impact. Very good. This is also possible. The superheating of refrigerant increases the work of the compressor. Of course, it is also possible. Let me show you the diagram. That's why you can able to understand. Right? I am drawing diagram of PS diagram of BCRS. All right. So it should be like this. It should be like this. It should be like this. So my dear, this is the first case and this is the second case. All right. So as you can see, 1 2 1 dash 2 dash 3 4. So this is superheated region, work input is increasing and refrigeration effect is also increasing. Therefore, my dear, all 3 points are correct. So option D is the correct answer for this question. Question number 92. In vapor compression, okay, refrigerator, the heat rejected in condenser is 1500 kilojoule per kg of refrigerant flow. The work done by compressor is 250 kilojoule per kg. The COP of the refrigerator is, we have to find out COP of the refrigerator, right? A very simple question, but here you can make one mistake. You will do what? You will consider this as refrigeration effect, but it is not exactly. For this we have to draw the diagram of refrigerator. It is showing heat rejected, that is what? 1500, and this is what? 250. Therefore this should be what? 1250, because 1250 plus 250 should be 1500 according to first law of thermodynamics, because Q1 plus W should be is equal to Q2. Therefore, my dear, now you can find out COP. COP is what? Desired effect, that is refrigeration effect, that is what? 1250. Division work input 250. So what we are getting, my dear? That is 5. So option A is the correct answer for this question. Question number 93. A refrigeration plant is designed to work between -3 degrees centigrade and 27 degrees centigrade. The plant works on the Carnot cycle. If the same plant is used as a heat pump system, then the COP of the heat pumps become. Alright. So my dear, it is very simple, right? So we need to just use temperature. That's it. Formula of heat pump. Desired effect 27 plus 273 TH by TH minus TL 30. So my dear, it is what we're getting, my dear. That is 300 division 30. So this cancel, so 10. So option A is the correct answer for this question. Question number 94. A refrigeration plant working on Carnot cycle is designed to take the load of 4 ton of refrigeration, that is 4 TR, and 1 TR is equal to how much? Kilowatt, 3.5 kilowatt, already asked in different examination. Also last time they have asked in Coal India examination, right? The cycle works between 2 degrees centigrade and 27 degrees centigrade. The power required to run the system is, so you have to find out power, right? Power required, that is COP of the refrigerator is TL by TL 2 plus 273 TH minus TL 25 is equal to what, my dear? That is 4 TR, that means 4 multiple 3.5. We have to find out W, that is power. So simplify this and tell the answer. Let me simplify. 4 multiple 3.5, that is 14. Division, that is what, my dear? 275 division 25. So 14 division 11, that is 1.27 kilowatt power required. power required is equal to what it is work done, similar, right? Both the same, 1.27. Therefore option A is the correct answer for this question. Question number 95. The COP of an ideal refrigerator of capacity 2.5 ton is 5. The power of the motor required to run the plant is, we have to find out power required. COP is equal to 2.5 multiple 3.5, power required is equal to 5. So W is equal to 2.5 multiple 3.5 division 5. So answer we are getting, my dear, what? 2.5 multiple 3.5 division 5 is equal to again 1.75. So option D is the correct answer for this question. Question number 96. In the working of a vapor compression refrigeration plant, the following enthalpies are recorded at salient points in the cycle. First, enthalpy at inlet of the compressor is this much. My dear, H1 is given, H2 is given, S3 is equal to H4. Therefore, COP, we know that in case of refrigerator for VCRS, H1 minus H4 division H2 minus H1, because refrigeration effect upon work input. So H1 minus H4, what we are getting, my dear? H1 minus H4, 150 we are getting, right? It is 150, and H2 minus H1, that is 30. So answer is what? 5. Therefore what, my dear? Option C is the correct answer for this question. Question number 97. Let's solve this. Consider the following statement in respect of the temperature of the medium, refrigerant, and the condenser and absorption system in a refrigeration unit. First, temperature of the medium being cooled must be below the evaporator. No, my dear, it is above the evaporator, so it is wrong. Refrigerant leaves the condenser is liquid. It is correct. Any solar thermally operated refrigeration system is capable of only intermediate operation. Yes, it is correct. So 2, 3, option 2, 3 and correct, right? It is correct only. So yeah, option C is the correct answer for this question. Question number 98. Which one of the following statement is correct? During heating and dehydration process, DVT increases. For that, my dear, we have to draw psychometry chart. Okay, let me draw here. It is saying heating is and dehumidification. So this will be like this, right? So in this case, what is happening? DVT increases. Yeah, of course, DVT increases because DVT will increase on the right side. As we'll go right side, DVT will increase. Therefore, option A is the correct answer. No need to see other options, but you must have to see, my dear, is there any option given all of these? Then you need to read other option too. Otherwise, not required to read. Question number 99. On a psychometry chart, what does a vertical upward line represent? What is representing basically? So we have to draw the psychometry chart we are drawing. All right. So vertically upward, that means what, my dear, it is happening? Humidification is going on, right? So option A is the correct answer. Question number 100. In winter air conditioning, the process is, so my dear, in winter we need humidification, right? And heating is also required, and further heating is also required. Therefore, my dear, option B is the correct answer for this question. So my dear, this is all about this session. Thank you very much for watching, my dear. Like this video, share with your friends, and of course, my dear, NLC test series we have launched, right? Already we have lots of students. So 65 tests we are providing for non-technical, 299 rupees price, my dear. Well, amazing platform, you will love it, and the link is in the description to buy this test series. For technical, we are providing 10 full length test series only for 149 rupees. Again, guys, that is for mechanical only, right? For a link is in the description as well as in the first comment. So must buy this test series. Thank you very much for watching. Bye bye. See you soon and take care. God bless you all.